first we are talking about the categories. Names will come later. Which test? That will come later. First let us talk about the category. So 5 cases are possible. The first is one sample test. The second and third, they belong to descriptive study, and 4 and 5 belong to experimental study. So you must choose your work. Are you going for descriptive study or experimental study? If it is a descriptive study, it can be 2 independent sample test. It can be K independent sample, that is category. The important thing to note here is its K independent category. K means any number more than 2, where K is any number greater than or equal to 2. It means 3 category, 4 category. Categories are many, but it is not variables are many. Take example, marks depends on parents' income. Parents' income may be high, medium, low, and marks are the actual marks. Now, if you look for which category it belongs to, which case it belongs to, number 1, it is a bivariate. Number 2, is it experimental research or descriptive research? Descriptive. In experimental, it is always again you measure something, right? Number 3, one of them is dependent, one in independent. So, hypothesis testing. The next point is, out of this income, how many categories are there? 3 categories. So, more than 2, so we will come to K independent sample, K independent category. If you apply T test, we can apply it between H and M and L, L and H. T works only on 2, okay. More than 2, it is always the K independent sample test, and the 2 possibilities here are F or H. Here the 2 possibilities are T and U, and here only T. These are the candidates. So, one block, second block, and now coming to the third block. If it is experimental research, before and after, we call it as 2 related sample and K related sample. Two related sample and K related sample. The candidates here are paired T or WMP, here it is RME or Friedman. Correct, equal to or more than 2, because number of people somehow they got a misconception that for the 2 only T is applied. I tell you, F, if you apply F, the results are same. Ma'am, T and F are from the same family. I will show you if possible today. T square is F. It is not possible that T and F will give you different results. If you have some idea about T and F, T says x1 bar minus x2 bar by standard error. F says it is the ratio of 2 variance. What is variance? X1 minus x1 bar whole square by n1, and this is x2 minus x2 bar whole square by n2. You cancel this. What it becomes? The square of T becomes F. Mathematically, it is not possible at all. Up to decimal place, you just square the T, it will become F. So, for the 2 independent sample, you can apply T as well as F. But for more than 2, T cannot work. T can work only in pair. So, this I will show you. So, absolutely, and if it comes to reference, so marketing research by Naresh Malhotra, it is clearly mentioned that one way ANOVA can be used for 2 or more categories. Okay. So, these are the 5 real life cases possible. So, this concludes our story of difference. Story of difference is why the things are different and what can be real life scenario. And we understood 2 methods of hypothesis testing decision, whether accept or reject. 2 decision methods are, one method is calculated value less than table value, means no significant difference. I am not writing at all hypothesis accepted rejected, I am simply saying no significant difference. Second is if p value greater than 0.05, it means no significant difference. Between what? Between two or more things, whatever you are comparing. Whatever you are comparing. So, two methods we have done. There is a third method also, lower limit, upper limit, we can skip it that for moment. Now, we can start with the Likert. Shall we go ahead?